Okay, everyone, thank you very much for attending. This is actually my first Jenkins World, and this is the first time I'm giving this session, so a day of firsts. We're going to be talking about containers and a little bit about the security of containers, and this is going to be a live exploit session. We're going to provide you with the red team view of how an attacker might come in and try and break into your containers from a number of different angles, and we're also going to look at how we can prevent, from the blue team point of view, how we can prevent a number of different attacks that could take place on our containers. A little bit about myself first. I run the DevRel team at a company called Snyk, and Snyk is a security company, developer-first security company that provide tooling to find and fix vulnerabilities both in your applications as well as your containers. I'm very passionate about communities. I founded a community called the Virtual Java User Group. Any Java developers in here? Couple at the back. Go Java. Any Node developers or JavaScript? A few people. Anything else? Python, Go. Oh, quite a few Python, Go. Ruby, .NET. No .NET. Oh, no, you're chewing your pen. Sorry, I thought you were a .NET person. I also am one of the co-leaders for the London Java User Group, and one of the co-leaders for a community called the Secure Developer as well, which is a free community that people can join. And we just provide great content about security in general, different ecosystems and things like that. So you're more than welcome to go to the securedeveloper.com to join that. Snyk also just recently acquired DevSecCon, so I'm one of the co-leaders of DevSecCon, so hopefully maybe I'll see some of you in Seattle, Tel Aviv, or London over the coming months. And I've got some other awards from being in the Java space for about the last 20 years from university, so that's where I've spent most of my time. So we're going to jump straight in, and we're going to talk a little bit about cloud native and about how the different architectures of cloud native deployments can affect our security. We'll start when we think about how a monolith was deployed into a cloud, for example. You can see that typically you would have a host VM. That host VM would contain your application, potentially running on something like a WebSphere or whatever you choose to run. I was a developer on WebSphere for 12 years at IBM. Any WebSphere users here? A couple more happy and smiley than normal, actually. It's normally I'd say any WebSphere users, and the heads go down, and it's like, yes. Yes, I am. So yeah, we would have a number of functions in our application, but it would typically be a monolith-style deployment. And as part of that, the operating system would sit in that environment as well. And the cloud platform you sit it on would take care of things like the hardware, the network, all of those kind of things. But everything above that blue box, everything inside those host VMs, you need to take care of. So the split responsibility isn't actually too split right now. The vast majority of it is in your hands, and you're taking care of that. When we push over to something more of a container idea, obviously likely running in a cloud platform as well, we can see that what we do is we utilize our hardware better. We utilize the VM that our containers are going to be sitting in much, much better. We can scale in a more granular way as well because we are likely to break up our monolith application into mini services and deploy them in different containers. So we can scale our containers, but if we look inside the containers, we still have the operating system built into our containers or being used by our containers. And then we have a container orchestration underneath that. We look at the cloud platform. Yes, we have better hardware utilization. We have more flexibility because we can determine what our operating system in our containers is going to be. We have better cloud portability in the sense that we can move these containers around, and an easier elasticity in terms of how we can scale. If we were to go one step further, we look more into the serverless environment, and the serverless environment is where our functions is really all we need to care about, and as well as our kind of bindings and our services that we need to use. For example, if we're on AWS, you might have services for Dynamo or something like that. Now, the configuration and the functionality is what we as developers, we as DevOps folk, want to write and want to publish. Everything else is pushed down into the platform, and that includes the VMs, that includes the operating systems, and that includes the support and maintenance of those things. So when we think about where the shared responsibility exists in a serverless environment, a lot of the security responsibility for the platform actually gets pushed into the vendor who is providing us with the platform for our serverless environment. So Lambda's Amazon, for example. So we're going to be focusing on containers here, and we're going to look in this middle section, and we'll look at various different areas that an attacker might try to break in, and we'll show a couple of them as well. So first of all is the base image, or the parent image that we choose to adopt for our container. And this is a kind of bone of contention that a lot of people, when they try and choose which base image they want to use, they just grab one. They find one that works. They look at others and they say, yeah, I'll just grab that one as well. But very often, not too much thought is put into the type of image, what operating system that image is going to use, and so forth. Very often, base images and parent images are synonymous in containers, but what we're really talking about here is the parent image, the image that I have in my from clause, my from directive in my Docker file. Now, when we take a look at the operating system that we're going to be using, which is derived from our parent image, we can see that the number of vulnerabilities that exist in the Linux OS environments over the number of years, that is rapidly increasing on the number that is being disclosed. So this is, over time, the number of vulnerabilities being disclosed per flavor of Linux. We can see it doesn't really matter that one is above the other here. It matters that all of them are on the general increase. So what does that mean for Docker containers? Well, when we look at the top 10 Docker containers which are being used today from stats from Docker Hub, we can see that the top 10 containers, the top 10 images have over, or at least, 30 vulnerabilities in each. Okay? Node being obviously the best here with 580. And the way these images work, of course, is they build themselves up in layers. And this makes it extremely hard to extract vulnerabilities out because, a lot of the dependencies kind of go through and you depend on other people to kind of add them in. So there's a blank screen. But actually, what I wanted to talk about there was, in fact, going over to show you a little bit about how we can decide what kind of base images we can use. Just a quick thing just to say that everything that I use on SNCC today is going to be entirely free, so you're more than welcome to try this out yourselves at no cost as well. So I'm going to go over to KubeCon here, and I'm going to view my projects. And I want to grab a project. In this case, it's going to be a project that I've scanned from Docker Hub. Here it is. I'm going to open this up, and hopefully we'll see what we've done is we have tested the image. And as a result of that, we have found a number of vulnerabilities in the platform and the packages that certain package managers have pulled in. And as a result of testing that, we have connected this scan to the base image, to the Docker file that exists in GitHub, and we've looked at the current image that is currently running. And in this case, that's Node version 10.4.0 Slim. And Slim is, of course, a much smaller version of a distribution than your regular stretches or Jessies and things like that. So we are likely going to see far fewer vulnerabilities here than some of the larger flavors of the operating system. This is a big key, actually, because very often we just grab an operating system and we expect that one's going to be fine. And of course, the application will run on that, but there's going to be a vast amount of that underlying platform that you're not going to use. And as a result, vulnerabilities can exist in there and can easily be exploited. So the question is, do we even want to deploy with that? So choosing a Slim image, if you can, is very beneficial. We could also see that there are suggestions here that are being made about a minor upgrade and major upgrades that we can move on from there. And you can see from that how that affects our vulnerability count, in this case going from 166 to 87, and how that affects the high, medium, and low SEV vulnerabilities that we're including. Alternate images as well, if you wanted to actually move tag or move your distribution, you can equally do that and see how that will affect your base image. So understanding the base image that you're on and understanding what effect changing to a different image can have is very, very important. Yes? No. So this is not cumulative. So this is our current image. Which has, so the current image that we have right now, 10.4, has 166 vulnerabilities. Minor upgrade would be to 10.16. and that would be 87, so that wouldn't be cumulative. The split, of course, will be cumulative. So of those 87, 48 are high, 34 are medium, and 5 low. Any other questions? This is currently using SNCC. SNCC is its own scanner, yeah. And SNCC has 2 different types of scanners. We have an app scanner, and we have a container scanner as well. So this is running container scanning that I can either do, in this case, I ran a scan, I pointed it directly towards Docker Hub, and it grabbed the image from there, scanned it, and provided me with the results. You can also do that on the command line as well. So,
you say, is that free?
This is free, yes.
That scanner, vulnerability scanner is free.
Correct, yeah. There is a freemium tier and there are paid tiers. So depending on how much you use the scanners, both on the open source projects, for example, as well as closed source projects, there are limitations based on that, but you get a monthly freemium allowance. So in this case, there are 100 scans in Docker, 200 scans on applications, but if you wanted to use that on open source, it's entirely free and unlimited. Okay?
How is it different than the artifact-free X-ray or some other vulnerability?
Yeah, so the question was, how is it different from X-ray and a whole bunch of other things like that? I want to be clear that this is not a SNCC presentation, so I just want to, I'll take your question at the end. We also have a SNCC booth, so I'd love you to come over to the SNCC booth. You can grab some T-shirts and things like that. I'll answer very, very quickly, though. One of the biggest things is our database. We have our curated database that a whole bunch of security team analysts, both in Tel Aviv and London, curate. Plus, we have this very developer-first approach. So from your IDE, from GitHub, from a whole bunch of different places in your pipeline, you can test, and we also provide remediation. So we don't just tell you what the problem is, we tell you how to fix it, and we can do that via pull requests as well. So we can actually say, click, fix this vulnerability. It'll send a pull request to your repository with the minimum upgrade you need to fix that. There's a whole bunch else, but I don't want to turn this into a pitch. So. You can use it on your build environment as well. So the question was, can we use SNCC in the build environment? You can do things. You can reach out to a Docker Hub, an ECR, an ACR, or if you wanted to do it locally, you could just write SNCC test with a couple of extra parameters once you've done your Docker build, and then we'll test that local image. Okay, now we're up. Okay, so least privileged user. This is an interesting one because if we don't state what user we want the user directive with an actual user, do we know what the default is for which user gets used in that container? Root, exactly, right? This is a really insecure default. So one of the things that we want to do is make sure that in our Docker file, when we decide how we want to add that, create that user or whatever. In this case, I'm creating both a group and a user. So I'm creating a group user SJ Maple, and I say I want to use that user within my container. If we use root, and then of course the mapping back to my host machine is going to also be root as well, we can escalate the privileges there quite substantially. So we want to make sure that we create a user with the minimum privilege. And the concept behind this, minimum privilege, least privilege, is if we have an application, for example, and that application has access to a database but only needs to read from it, you wouldn't give it full privilege to read and write. Even if it's a mistake, something might accidentally overwrite something in the database, but we certainly don't want an attacker to get in. And when an attacker gets in, we want to limit their privileges. And I say when an attacker gets in, not if an attacker gets in, because it's more than possible. We have to code as if an attacker is going to get in. So we want to make sure that they have the minimum privilege that they can. So when they get into a place, they can't see anything. They can see only just what they need to see from a service's point of view, and that ability in terms of permissions as well. So people who favor Node, if you want to use Node with something like Alpine, there's a default Node user which is built in, and that Node user you can just say user Node. You don't need to create anything necessarily, and that will give you the reduced privileges as well for that application. Okay, we're going to talk a little bit about signing now and using verified images. And to be honest, there aren't a huge number of verified images on Docker right now, but one of the big reasons about verifying an image is that when we download an image, we want to make sure that that image is the same version of the image, or it's not even the same version, but the identical image that the publisher actually pushed up. Okay, so we don't want to have a man-in-the-middle attack whereby someone is sitting in between, can augment that image and send me a potentially malicious or in any way tampered with image. So what can we do? Well, we can prefer signed images. This is obviously Docker Hub, and you can see this is the list of Docker certified images. These are images that have been signed, and when we download it, we know and we can test that that signed image is the exact same binary file that a publisher uploaded into Docker Hub. We can also sign images ourselves and use Notary in a couple of ways, and this is a link to the Docker Hub. To the Docker docs where you can see and get started with Notary. But you can sign your images before you publish them. Plus, what you can do is you can also test your images when you download them and make sure that you aren't pulling and aren't publishing, pushing up any unsigned content. You can also test. If the files that you are downloading, the Docker on Docker pull is signed by using this environment variable here, the Docker content trust equals 1. If you set this environment variable up and then do a Docker pull, you can only pull signed images down. So you can use this as a test to make sure that the content that you are pulling down is actually verified and signed. Okay, now we're going to do a little hack, our first hack, and this is about how we can find and fix issues and vulnerabilities that exist in our operating system level. So obviously, with the container, we are responsible for the OS. And let's take a couple of stats. Here, this is actually stats from the State of Open Source Security report, which we published on the SNCC blog. It's entirely ungated. You're more than welcome just to go down and check it out. It's just a PDF. The link is actually at the bottom there. When do people scan for operating system vulnerabilities? Well, a lot of people do it at build time. It's more common, particularly in containers, for people to do that rather than shifting fully left to the developers. And it also depends on which is the persona, which is the people in the team that actually build those Docker containers and support those Docker containers. We can see that half the people don't scan for operating system vulnerabilities, which is pretty shocking. And again, this is This is one example of how you can do this. There are a number of different models number of different scanners that you can use. This is the example the gentleman was asking if you can do this locally. You can do a SNCC test, and that will provide you with a list of vulnerabilities in your operating system as well as packages. And the other thing is, once you've actually then deployed your application, how do you monitor that? And the way we monitor it, even though one in two almost don't, the way you monitor it is by taking a snapshot. And you can do this with something like a SNCC monitor. And that snapshot will then have SNCC test every single day to make sure there are no new vulnerabilities. And where new vulnerabilities do exist, we'll email you or send you a notification in your preferred channel that this has happened. So you get notified daily as and when new vulnerabilities or new fixes potentially are available. So I want to provide you with some other insights that we have as a company. We have a lot of people using our tool to scan with. And I want to share some insights about some of the fixes that people can do very, very easily. We noticed that 44% of the Docker images that were scanned on our platform had known vulnerabilities that could be fixed just by switching a base image to a very simple base image, which wouldn't really affect the application at all. So almost 1 in 2 are likely on a base image or a parent image that is less secure than one that they could be on. Even more shocking is that 1 in 5 can fix a number of vulnerabilities just by simply doing a Docker build. So doing a rebuild, making sure that you have the latest dependencies in, and then publishing that, you will then likely have fewer vulnerabilities as well. So again, this one, there's absolutely nothing to do there. You just run a Docker build. You don't even need to change your environment. It's all done in the background for you. Okay, we're going to attack a Docker container now, and we're going to do this via a package which is installed via a Debian install. And this is going to be an improper input validation that is going to provide us with a remote code execution. And this is a vulnerability that exists in a package called Magic, Image Magic. Anyone heard of Image Magic? Quite a few people. Cool. Anyone know the vulnerability I'm going to hack? And there's a big thumbs down there from this gentleman over here. Not a fan, huh? Anyone know the vulnerability that we're going to hack? A PNG. It's a really nice vulnerability called image tragic rather than image magic, which is very pleasing. So let's go and actually make this hack. So I have an application which here is going to be using image magic. It's a very straightforward application. Upload an image to convert it to a Twitter ideal photo size, which is really these days our main goal, right? To have a good Twitter photo. So I'm going to choose a file. Let's grab a file. The file I'm going to choose. What do we have here? Let's grab that screenshot that I just used. I'll click resize, and we have this amazing Twitter image that we can use, which is actually a screenshot of the vulnerability I'm going to be exploiting now. So this is what this application does. It's running in a container. If I show you the container we are currently running in, this is our SSH into this container. So if I was to do, what is it called? Convert. There we go. There's image magic running an insecure version that I know to be insecure. So what we're going to do is, the way this works is image magic will look at the file that you pass it. It won't even actually look at the extension, but what it'll do is it will go through line by line trying to work out what the file is and then try and reduce this file. As a result, as part of this, we can escape the strings that we're adding into this file and potentially execute some code. Let me show you an example of a file that we are going to, and in fact, I'll just do an ls there so you can see I have cleaned this from the last time I ran it. Yep, we'll use that in just a second as well. Let's take a look at the file that we are going to use, if I can find it. Where am I here? Okay, the file that we're going to upload is RCE JPEG. So if I cat that, you'll see. Is the text okay for everyone at the back, by the way? We are good, excellent. So here we can see we're gonna create a graphic. We're gonna create a box which is 640 by 480, and we're gonna fill that, and we're gonna pass a URL of the image that we want to fill that with. But what we're doing is we're breaking out of the string. We're gonna provide just an OR, and then we're gonna just touch a file just to show that we can actually do something. We can actually run some remote code execution. So that's all we need to do. Let's go back straight over to here, and let's choose a file. This time, we're going to use the exploits RCE1. I'll resize that. The resizing succeeded. There's just an empty file there. But if I come back here and I do an ls, we now have an RC1 file that we've catted. So now we have remote code execution. Okay, we can see how we can do that. Now let's do something a little bit more interesting. And what I'm going to do is, first of all, from this directory here, where we have netcat and r.sh, I'm going to use this as a serve. And by using that as a serve, I can now access that from outside. There we go, it's serving. Now I'm going to show you my rce2.jpg. So let's cat rce2.jpg. Now what we're doing is we're doing it in a subtly different way, but we're going to do a similar thing. Here we're going to do an image over. We pass in a URL, but this is now using this little I'm not sure exactly what that's called, but it's like a single quote kind of thing. That's now going to provide some string which needs to be evaluated within this, and it's going to be evaluated locally. So now what we're going to do is we're going to wget. We're going to wget something which is being served that I just grabbed. We're going to serve r.sh, and then we're going to bash that. Okay, so we're going to grab that content, put it into a file called r.sh, and bash that script. Let's have a look at r.sh. With r.sh, we're going to wget netcat, and we're going to grab that, we're going to configure it, and then we're going to execute it, and we're going to point it back to my local host, pointing towards port 3131. We can also use a different port if a firewall is restricting that. I'm going to go and set up a little listener. Where's that listener? Here we go. This is my netcat listener, which I'm going to be running on 3131. That's now running there. So now, once that kicks off, I should be able to have this nice little connection that I should be able to send commands to. So now, let's hopefully, if this works, let's create a file, RCE2, open that file, let's click resize, and what that's doing now is that's currently downloading from my served file. Netcat is opening it up, it's running it, connecting to my listener port. So in theory, if I come over here and type ls, we get the ls of my Docker container. Now this is an interactive console, and I can execute whatever I want. So I can have a look where I am. I can ps-ef. I can cat my etc password just for a bit of fun. Okay, I have remote control access over that container. Any questions? Everyone want to upgrade so that they're not using an insecure version of ImageMagick? Yeah. Awesome. And that's it. That's the fix. There is an insecure version of ImageMagick. There is a secure version of ImageMagick. This distribution is using the insecure. To use the secure, we upgrade to a version that pulls in the secure version. Okay, that's a bit of good fun. Let's see, how much time have we got left? 56. Cool. So we have a few more to do. Use a linter. I'm a big fan of linters, actually, because I'm a big fan of, when we make rules, policing rules. And linters are a great way of actually policing those rules. One of the things that we can use is something called HadoLint. I think it's HadoLint. It might be HadoLint, but I would say HadoLint. And this is a linter that makes sure that we don't do silly things in our Docker file. The configuration that we add is using the right thing. And so we can see here, for example, we need to pin versions in our app to get install. We need to delete the app to get lists after installing. We need to use copy instead of add for files and folders because there are insecurities in add. So this is a great way of being able to police what we actually push as well. So HadoLint. Let's talk about that last point on HadoLint as well, and that was, let's use copy instead of add. And this is obviously in our Docker files. Now, the reason we use copy instead of add primarily is because add will allow us to actually pass in remote URLs that we can then create locally. And one of the big things about doing that, there are two reasons. First of all, the first reason is when we do that, we could easily go to an insecure location, and as a result, have man-in-the-middle attacks. The second reason is when add can grab an archive, that archive can be extracted locally, and it does it without doing it in a secure way. So it'll extract an archive without validating our inputs. And I won't give you too much more because I'm going to ask you about where this vulnerability exists in my code in just a second. But this vulnerability is something which was coined as zip slip by Danny Grander, who is our security lead at SNCC. One of the things that we do as well as our project, we do a lot of open source community work, and as part of that, we do a lot of research in vulnerabilities. And zip slip is an interesting arbitrary code overwrite. Arbitrary file overwrite, whereby when we extract something, we can potentially overwrite files that we don't intend to overwrite. So this is Danny Grander. He's the guy at the back, not the dog, and yeah, one of the co-founders at SNCC as well. So I want to show you this, where this vulnerability can exist. So here's a piece of code. And this code, this is Java code, and it's very interesting that Java doesn't actually have in its core libraries a way of extracting an archive. So a lot of people will, and I'm actually doing a bigger session on this, I think, tomorrow, called Zip Slip, Stack Overflow, the vulnerability marketplace, because what happens is people go to Stack Overflow and say, how do I do this? And someone will go, oh yeah, here's a piece of code, do that. And this code is vulnerable. And it's a very similar example to this. This code is vulnerable, and it will get hundreds and hundreds of upvotes because it functionally works. And there'll be one comment way down that says, oh, by the way, this code is vulnerable. This is what you need to do. And that will have like 3 upvotes. And this is the world we live in, right? Because people copy-paste all the time. And when people push vulnerable code, that's very easily copy-pasted. So tell me on this. Let me go through this. What we do is we have a destination directory. We have a zip file that we're pulling in, a third-party zip file. We enumerate that into a number of zip entries. We go through that. For each element, what we do is we create a file. That file is a combination of concatenation of our destination directory as well as the name in our file in our zip path. Then we create an input stream and copy that to a file. Wow, Java's verbose. Even talking about it is verbose. Okay, which line is the vulnerability in this example? Sir? 25, let me see. It is, and why is that vulnerable?
You're not checking that you're assigned to the destination directory.
Exactly right. So the vulnerability here is that we could actually traverse out of the directory that we intend to push this, extract this file into. If we had For example, an e.getName, which was something like ... and then my file, we are not putting that in the destination directory, because when we concatenate these two, we are breaking out of the destination directory and then potentially overwriting other files on our file system. I could go back even further and overwrite, some private key or some API key or whatever I want. Okay, and again, this is very much depending on what, where I am, which permissions I have, what user I'm running under as well. The fix, and this is even more verbose, my goodness. What we do is we use the canonical destination, and when we concatenate these two, we make sure that the canonical version of that, so effectively the flattened version of that, still starts with the destination directory. So am I now, once all of the ... slashes have gone and we're in the actual directory that we want to put this in, does this start with the target directory that I want to deploy it to? And that's how we avoid that. Okay, finding and fixing and monitoring the actual application vulnerabilities, because one of the things that we haven't talked about, of course, is the application, which is one of the big ways in which people can attack. And let's, have I got any more? Oh, I have got a few slides. I don't want to go through too many, though. When we look at your applications, what we think about is the code that you write in your IDE, but that's not the major part of your application. The major part is the application that you actually deploy. In fact, I don't think I've got it here, but I probably have it in another window. Let's do this and go to here. Let's have a little game here. Oh, you might have got the answer then. Here's a serverless file. This serverless application is 19 lines of code, just 19 lines. So we as developers think, wow, that's amazing. In just 19 lines of code, I've written an application that can grab a file, fetch a file, and store it up in Amazon's S3. Amazing. We have just 2 direct dependencies. How many indirect dependencies do you think this has? And you laugh because it's Node, but it's not that bad. Any guesses? 9? 8? 19. So 17 indirect dependencies. In total, 19 dependencies. Not too bad for an NPM like application. How many lines of code do you think we're deploying? Remember, we only wrote 19 lines, but from the point of view of the production environment, what are we actually deploying? How many lines do you think? Just shout out guesses. 3K? Any other? 20K? 300K. Closer to that, almost 200K, right? So this 19 lines of code that we're writing that we think we're amazing developers because this is amazing. Look at the functionality I've pulled in. What we're actually deploying is 200,000 almost. And the 200,000 is what we need to maintain and what we need to secure. Because it doesn't matter to an attacker whether they're going in through your code or open source code. They care about actually getting in and performing a breach. So, attackers are targeting open source. And one of the big reasons of that is because one vulnerability can have many, many victims. And by that, I mean if someone attacks, if there's a vulnerability in something like Apache Struts or Jackson, that is used by hundreds and thousands of applications. If there's a vulnerability in there, there could be a whole bunch of victims that we can just go out and try. Whereas if it's your proprietary code, it's only going to affect you if the vulnerability exists there. So I don't want to go into too many more stats, but there is a couple that I want to show you. And the first one is the rate of increase in open source. And we can see the number of NPM in particular, number of packages being indexed into NPM registry. And this is like 250,000 new indexed packages last year. It's actually over 1 million right now. And I spoke with someone on Twitter a few months back when the million happened, and he said, what do I get for being the millionth person to publish a package? And I replied to him saying, how do you know you're the millionth person? You don't get a number back from NPM. And he said, what I did was I wrote a script that when it hit 999,960, I published 40 packages. And I thought, okay, it works, I guess. And those 40 packages probably aren't the worst on NPM registry today, but that's the world we live in. And with that, when we think about how our applications are structured, we think we have direct dependencies and transitive dependencies. The vulnerabilities tend to exist in the transitive dependencies, and this is largely because of the way the dependency graph builds itself. As I said, we had 2 direct dependencies in that previous application and a further 17 transitive dependencies. So the vulnerabilities are naturally going to more likely exist in the transitives because there are plain more of them. As a general rule, you are likely to be more exploitable by vulnerabilities in your direct dependencies than your transitives just because you're more likely to be going through those code paths. Very general rule. So let's go to this application right here, which is actually running on my, in a Docker container running on my local machine. And what we're going to try and do is we're going to try and get access to that Docker container and see some sensitive information. So we have an application here. It's just a to-do application. I can buy some milk. I can buy something really important if I wanted to, like some beer with stars, and those stars mean it turns bold. So we have some markup support in there. I also have an about box here, and this about box is serving the about HTML, very, very modest package. Now I've actually already scanned this, and I can see from my scan results, if I go into projects, I can see from my scan results that there's going to be a vulnerability called directory traversal. Who's heard of directory traversal? Yeah, sir, what's directory traversal? Please tell us.
Adding to an input //
Yep, and the goal of this is to break out of a directory that we have access to. So if we are serving something from a directory, and the project that we're going to attack here is called ST, here it is, directory traversal in ST. ST is a package that serves static content, and it provides it from a directory. So what we want to do is break out of the directory it provides us with so we can read other aspects of that file system, other sensitive information. So knowing that, and from just what I've shown you in this file, in this application, how do you think we can perform directory traversal on this application? Everyone always jumps to choose file. That's another vulnerability. This is an application. That's an application that we create that has known vulnerabilities through existing packages. But that's a different vulnerability. Sir, in the URL, absolutely. So the way we do that is through the about. So if I grab this, let's be proper hackers and go to a command line. Let's do it here. No, not here. That's my. Let's do it here. So if I curl that, you can see how amazing this application, how durable it is. It looks just as good here as it does in the browser, right? So if I wanted to do a .. something like this, yeah. We run that, and it gives us no, it doesn't give us an error. It takes us to the home page. Okay, because ST is a library. ST knows that we're going to be trying to do this. So it recognizes the .. and so it says, no, you're not doing a .. because .. is directory traversal. It recognizes the dots. Any other way we can write that? Say again? Escape the dots. Something like this. Escape the dots, we still get there. So it's not about the dots not getting through. It's about the way they're getting through. Sir? URL encode it. How do we URL encode a dot? Do you know what a URL encoding of a dot is? Anyone? %2, %20. %20 is a space. I think you said 20. That's it, 20. That's it, perfect. Someone got it there. You know who the hackers are when someone just pulls out %2e. So whoever said that, I have my eye on you. So we do %2e, %2e, and there we go. Bang, we have directory traversal. We know we're outside because there's the public directory we were in. Okay, so thinking from an attacker's point of view, what do we do now? Say again? Do it again? How many times? Should we just keep doing it? CD ... in the root is the root, so there's the root. Anything you want to see? Shall I show you a cliche? But this is in a Docker container. So this is the etc password of my Docker container. Other things I can do. One thing that's very, very useful here is the package JSON. So from here, I have my package JSON. I see all the other things. And these things can actually get me, these other dependencies can get me more information about the application running in that Docker container, provide me with more privileges, get to that glory world of a remote code execution on a root or something like that, okay? This is how we start beginning. This is only a medium severity vulnerability, and it's only a medium sev because we can read. We can't change, okay? So Hacking the application, another great way of getting into a Docker container. Okay, so Gone Terminal. One of the last ones that we're going to talk about is using multistage build for small and secure images. So multistage build allows us to, when we start creating our Docker container and we start doing things in our Docker container, like, for example, compilation, creating applications, those kind of things, the things that we require and depend upon in those first stages are only to get us the application in a state that we want to actually deploy it in, for example. We don't necessarily still want those dependencies to exist in production, because once we're in production, we care about the application existing, not all the other tools and dependencies that were there to get the application in that state. So with multi-builds, what we can do is we can have various, and we can do this with directives in our Docker files to say, I want this to actually persist through to my final Docker image. And what we do is we have various images. The first image, and Golang is a good example of this, whereby we have a very large image, which is bundled with a whole bunch of dependencies that are used to build our application. And once that application's built, just the parts that we are using that we want to push, bless you, that we want to push into our production environment, just those parts are what is left. So when we create our second image, our next image, image B, we only have those. We don't have the vulnerabilities, the dependencies that can exist in our other instances. So this will also help us with a reduced size of container, reduced size of container that obviously will have fewer vulnerabilities. So with a few minutes left, we have a number here. I'm not going to go through them all again, but a number here of things that we can look at and things that we can improve in our process about, particularly with things like linters and things like that, to police how we do things. And a lot of this can be added into our pipeline as well. So if we think about a DevOps-style pipeline where throughout that pipeline, from the very beginning, from developers going all the way through, we need to be testing and checking from our IDEs into our repositories, into our CI, and pushing into our production environments. But we don't stop there. We then monitor our production environments to make sure that if anything did happen, if new vulnerabilities did arise, we knew about them straight away. Even without going through that build pipeline, we know about them straight away. With a few minutes left, I'm happy to take any questions you might have, and I'll also just repeat that if anyone wants to come to me and talk about some of the SNCC things I showed, happy to talk about them here. We also have a booth just opposite where we can go into much deeper demos. I don't too much want to do it on stage, but I'm very happy to do it at our booth. And we have a whole bunch of swag, including stickers, magic wands, T-shirts, and a whole bunch of other things for you. So, yes, sir, at the back. Say again, sorry?
Starting the containers, how do you check on privileges? People start to lock the container without having privileges. How do you stop that? How does you guys have them on best practices on that?
Best practices in privileges that people have? Oh, I see, starting with low privileges and building up. Yeah, and I think, so this is actually a kind of a general rule in security as well about when you start adding privileges into people, into users or whatever. And it's a classic, happens very much in serverless as well, when people deploy a whole bunch of serverless applications. And in fact, I can give you a very good example on the serverless case. If I was to show you, in a serverless YAML, what you'll effectively have is these kind of like role statements and things like that. And what people do is they just try to make it work, okay? And they do that just by providing a large number of permissions, a large number of granting people the ability to do whatever they want to do. And sometimes when you deploy that together and you actually have people sharing roles, then people will naturally have more permissions than they need to, because by sharing roles, one service and another service, they could potentially be doing very different things but sharing the same security permissions. So to have granular permissions depending on what the service that you're actually having is doing is very, very important, because you only add permissions, you never remove permissions. Why do you never remove permissions? Because you're frightened of breaking something, okay? You only get to star, you never come back from star, okay? When you go to all permissions, no one wants to remove that because no one knows what needs it, what's using it. So starting early and having split roles is one of the best keys. And again, that's not just for containers. That's a good general rule in security. Any other questions? So.
Is there any easy way to prevent people using the root privileges with containers? I mean, to lint it out or?
Yeah, no, linting is one of the best ways. Yes. If you have so the question is if you have a base image is using root privileges, which is I think quite rare because I think well not rare. Let's not say rare. That's a bit stupid. But it's unusual for a well-used Docker base image to have such privileges. But I would say linting is a good way. Linting is a good way of doing it. Making sure that you have within your companies policies about the best practices, and that will include things like making sure people are using user and things like that in their Docker files. That's the most important thing. Most linters will catch that kind of thing as well. Sir. Not so much necessarily Node. Any compilation languages are good for that as well. So your Javas and things like that. Also, depending on it massively depends on how people actually construct their applications. Some people construct things locally and then try and move that into a container. In which case, you're likely going to end up with a small container at the end anyway. Some people like to build their container, put all the files in, build it up in that local environment, and run it. So yeah, compilation languages are a classic for that. Any other questions? Awesome. Thank you very, very much for attending. Thank you for your time. Hope you enjoyed the session.